Hello friends and welcome to our channel Target Jam. Today we will discuss about aromaticity part 1 and mainly about Hueckel's rule, and then we will practice few questions depending on aromaticity and Hueckel rules. Let's start. For a cyclic conjugated polyenes, there will be a single lowest energy MO and the other MOs will be present as degenerate pairs. So the number of available bonding MOs is 2n plus 1. See, in this case, the first one is the single one and the others appears as a double. That means degenerate pairs. So there will be total 2n plus 1 number of bonding MO, and to fulfill this 2n plus number of bonding MOs there will be 4n plus 2 numbers of electrons will be required. And from this Hueckel's rule was derived as if a cyclic planar system contains 4n plus 2 pi electrons for n equal to 0, 1, 2, 3 etc., which are capable of forming a closed shell, the system will be aromatic. See, here the four conditions are there. Number 1, cyclic, then planar, then 4n plus 2 pi electrons, and then forming a closed shell. See, we have to remember these four conditions to check the aromaticity of any cyclic compounds. For the counting of pi electrons for neutral cyclic polyenes, the number of carbon atom, that is number of p electrons, equal to the number of pi electrons. See, in this case benzene has 6 carbon and 6 p orbital, so 6 p electron, and another way we can calculate, there is 3 pi orbital, so 3 into 2 equal to 6 pi electron. For charged cyclic polyene, the number of carbon atoms plus minus number of charges equal to number of pi electrons. For example, see, in this case the number of carbon atom equal to 5, number of charge equal to minus 1, so the number of pi electrons equal to 5 minus of minus 1 equal to 6. And in case of this cation, the number of carbon equal to 5 and the number of charge equal to plus 1, so the number of pi electrons equal to 5 minus of plus 1 equal to 4. The pi electron counting is important to assign the aromaticity of a particular compound. Now we are entering to the MCQ practice. Question 1. Identify the incorrect statement regarding aromaticity. Option A. It is the extra stability possessed by a molecule. Option B. p orbitals must be planar and overlap. Option C. Cyclic delocalization takes place. And option D. It does not follow Hueckel's rule. Identify which one is the wrong statement about aromaticity. Choose the correct one, and we are now going to check the answer key. The right option is option D, that is, it does not follow Hueckel's rule. This is the wrong statement about aromaticity. Question 2. Which are the aromatic molecules among the following? See the structure of these four compounds and which one is the aromatic. Option A, 1 and 3. Option B, 2 and 4. Option C, only 2. Option D, only 4. Choose the correct option for aromatic molecules. We are now going to check the answer key, and the right option is option B, that is 2 and 4 are the aromatic compounds. See, the compound 1, there is a 1 double bond but 1 sp3 carbon is there, so it is non-aromatic. In case of compound 2, in presence of SbCl5, it generates the cyclopropynyl cation, which have 2 pi electrons, that is, it follows the 4n plus 2 pi electrons for Hueckel's rule, that is for n equal to 0, and it is cyclic, planar and conjugated, so it is the aromatic one. And in case of compound 3, there is 2 sp3 carbons, so it is non-aromatic. And in case of compound 4, there is a charge separation to get the aromaticity, so compound 2 and 4 are the aromatic compounds. Question 3. Find the correct CO bond length order in the following molecules. There are 3 molecules, therefore they have each one they have one carbonyl group, and you have to find the correct CO bond length order. Option A, 1 greater than 2 greater than 3. Option B, 2 greater than 3 greater than 1. Option C, 3 greater than 2 greater than 1. Option D, 3 greater than 1 greater than 2. Choose the correct order of CO bond length. And we are now going to check the answer key. The right option is option D, that is 3. It is the longest CO bond and 2 has the smallest CO bond length. See, in case of compound 2, the sp2 hybridized carbon, the normal bond angle will be 120, but here the C bond length, bond angle is 60 degree. So the CC bond have higher P character, and that's why CO bond will have more S character. That means more S character means small bond length. So in case of compound 2, the CO bond length will be smallest, and in case of compound 3, due to the gain of aromaticity, the CO double bond will have some single bond character, so bond length will be higher. So the compound 3 will have the longest CO bond length among these 3 compounds. Question 4. Choose the correct aromatic molecules among the following. See, the 4 options are there, and we have to find the correct aromatic molecules. Option A, 1 only. Option B, 2 and 3. Option C, 1 and 4. Option D, 4 only. Choose the correct option. We are now going to check the answer key, and the right option is option D, that is only 4 is the aromatic compound. See, in this case, the number of pi electrons equal to 4, so it violates the 4n plus 2 rule. In case of compound 2, the number of pi electrons equal to 2, but it has 2 sp3 carbons which inhibits the conjugation, so it is non-aromatic. In case of compound 3, one carbocation generates, but another sp3 carbon inhibits the conjugation, so it also non-aromatic. And in case of compound 4, this dication formation occurs, and which is number of pi electrons equal to 2, so it follows the 4n plus 2 pi electrons rule for n equal to 0, and it is cyclic, planar and conjugated, so it is the only aromatic compound. Question 5. Which of the following compounds have aromatic character? See, the 4 options are there, 1, 2, 3 and 4. Among these 4, which one is or are aromatic ones? Option A, 1 and 2. Option B, 1 and 3. Option C, 1 and 4. Option D, 2 and 4. Choose the correct option about aromatic compounds. And we are now going to check the answer key. The right option is option D, that is 2 and 4 are the aromatic compounds. See, in case of compound 1, the number of pi electrons equal to 4, so it violates the 4n plus 2 rule, so that is it is non-aromatic. And in case of compound 2, the in presence of Grignard reagent, that is a methyl magnesium bromide, and it abstracts the proton to form this anion, and the number of pi electrons is equal to 6, and it is also cyclic, planar and conjugated, so this one is the aromatic compound. In case of compound 3, the number of pi electrons is equal to 2, but in 5-member ring there is 4 carbon is sp3 hybridized, and in case of cyclopropene ring, 2 sp3 carbons is is sp3. So it is non-aromatic. And in case of compound 4, there is a charge separation occurs to form this dipolar molecule. Each of these two rings are aromatic character because each of these follows the Hueckel's rules, that is 6 and 2 electrons, cyclic, planar and conjugated, so 2 rings are aromatic. So the structure 2 and 4 are the aromatic one. Question 6. Find the correct statement about the following reaction of tropylium bromide. See this reaction of tropyl bromide, and bromine is replaced by the ethoxide, and star C, that means 14C labeled carbon. Option A, isotope labeling will remain 100% intact at C1. Option B, isotope labeling will distribute among C1, C3 and C6. Option C, isotope labeling will distribute among C1, C3, C4, C5 and C6. Option D, isotope labeling will distribute equally to all the carbons. Choose the correct option about this reaction and the distribution of 14C labeling. We are now going to check the answer key, and the right option is option D, that is isotope labeling will distribute equally to all the carbons. And this is because in presence of silver nitrate, it loses bromide, so it forms the tropylium cation, which tropylium ion is the one of the highly stable carbocation. Its stabilization arises due to the gaining of aromaticity, that is 4n plus 2 equal to 6 pi electrons, and also cyclic, planar and conjugated. When it gets aromatized and stabilized, then all the carbons becomes equivalent. So the radio labeling will distribute equal to all the carbon, and then ethoxide can attract to any of the carbon atom to form the final compound. So the isotope labeling will distribute equally to all the carbons. Question 7. Select the correct statement regarding the aromatic nitrogen molecule. Select the correct statement regarding the aromatic nitrogen molecule. Option A, it is not hybridized. Option B, it is sp hybridized. Option C, it is sp2 hybridized. Option D, it is sp3 hybridized. Choose the correct one about the aromaticity and the hybridization of nitrogen in aromatic nitrogen containing molecules. We are now going to check the answer key, and the right option is option C, that is it is sp2 hybridized. See, in this pyridine molecule, nitrogen present in the aromatic ring, and it is sp2 hybridized. Question 8. Which of the following will have aromatic character? See these 4 molecules, and in presence of some reagents, which one will have aromatic character? Option A, 1 only. Option B, 2 and 3 only. Option C, 4 only. Option D, none of the above. Choose the correct option about the aromatic character of these 4 among these 4 molecules. We are now going to check the answer key, and the right option is option C, that is compound 4 will have aromatic character. See, in this case, in presence of potassium and THF, it forms the dianion, which will have 8 minus or minus 2 equal to 8 plus 2 equal to 10 pi electrons. That is, it follows the 4n plus 2 pi electron rules. It is also cyclic, planar and conjugated, so it will have aromatic character. But compound 1, 2 and 3, they does not follow the 4n plus 2 pi electrons rules. Question 9. Which of the following molecules will have aromatic stability? See these 3 molecules and find which one will have aromatic stability. Option A, 1 and 2. Option B, 2 and 3. Option C, 1, 2 and 3. Option D, 3 only. Choose the correct option. We are now going to check the answer key, and the right option is Option B, that is compound 2 and 3 will have aromatic character. See, all have 4n plus 2 equal to 10 electrons, but in case of compound 1 there will be a 2 hydrogen inside the ring, that is transannular position. So there will be strong severe repulsion between these 2 hydrogen, which will destabilize the molecule. So it will be non-aromatic, as because it loses the polarity. Due to strong transannular interaction between 2 hydrogen atoms, as shown, the ring will no longer remain planar, and also it will be highly unstable, so it cannot be prepared. So it is the not aromatic. Question 10. Find the aromatic compounds among the following. There are 4 heterocyclic compounds. You have to find the aromatic compounds among these 4 compounds. Option A, 1, 2 and 3. Option B, 1 and 3. Option C, 2 and 4. Option D, all the above. Choose the correct option. We are now going to check the answer key, and the right option is option D, that is all the above are aromatic. See, compound 1, 2 and 3, that is furan, pyrrole and thiophene. For these compounds, one lone pair in p orbital participate in the forming the closed shell. So total number of pi electrons is equal to 4 plus 2. So it is they are aromatic. And pyrrole is the weak base, because if the lone pair is coordinated to a proton, then aromaticity will be lost, which is energetically unfavorable. And in case of pyridine, it is quite a strong base, because here the lone pair is not participating in the aromaticity. So if it donates its lone pair to a proton, then also it does not loses the aromaticity, and that is why it is a good base. Now calculate your performance. Each question carry 3 points, negative attempt equal to -1 and unattempt equal to 0. Then evaluate your performance, and in our next tutorial we will see about aromaticity part 2. Thank you very much for being with us. Thank you.